In this video, we're going to go over how we convert pyruvate to acetyl coenzyme A, which can then be used in the citric acid cycle. So first, we're just going to start with the enzymes that do our chemistry from us. As I mentioned in the previous video, acetyl-CoA can come from fatty acids, amino acids, but we're going to focus on pyruvate here. And the enzyme or enzymes that do this, pyruvate dehydrogenase, is what we call a multi-enzyme complex. What that means is that you have a bunch of enzymes that are non-covalently associated, so no covalent bonds, hydrogen bonds, hydrophobic interactions, ionic bonds, all that stuff. And they catalyze two or more sequential steps in a metabolic pathway. This has some distinct advantages. Because all your enzymes are close together, the substrates don't really need to travel far until their next reaction happens. This means your reaction will, overall, your whole pathway will go faster because you're not losing time in traveling. And since you're funneling intermediates from one enzyme to another, there's less chance that these intermediates will react with other molecules. You won't have any side reactions when you're doing this channeling. Also, since everything's right next to each other, you can control the overall flow of these enzymes coordinately. So it's easy to block them all at once or turn them all on at once. So the complex itself, pyruvate dehydrogenase, is made out of three enzymes and multiple copies of those three enzymes. So it's a little confusing, but the first enzyme is called pyruvate dehydrogenase as well. Then you have dihydrolipoyl transacetylase, that's our second enzyme. Then dihydrolipoyl dehydrogenase as our third enzyme. Now for E. coli, you have your core made up of 24 E2s that are in like a cube-like shape. And surrounding that cube, you have 24 E1s and 12 E3s. So you can see that they're all really close to each other and connected. Mammals, yeast, and some bacteria, it can be more complex than what's being shown here. And it is the largest known multi-enzyme complex we have found. Note, when you're talking about mammals, mammals actually have an additional protein that's called the E3 binding protein, which facilitates binding of E3 to E2. It also has multiple kinases and phosphatases that will regulate these proteins. But we're going to focus on the E. coli system first, as it's simpler than the mammalian system. So pyruvate dehydrogenase, there's 5 reactions that we're going to look at. The overall reaction is pyruvate plus coenzyme A plus NAD plus goes to acetyl-CoA plus carbon dioxide plus NADH. So we have 5 different cofactors, not enzymes, that are required here. We need TPP, thiamine pyrophosphate, which we already talked about, lipoamide, coenzyme A, FAD, and NAD+. And I have their list of where they're located and what they do, but we'll also see this when we go through all the steps. But use this table as a reference when you go back to looking at this mechanism. And that's it for this video. I will see you in the next one where we go over the steps of pyruvate dehydrogenase complex.